36. JJ.
You always go from left to right when doing this?
You could do it from right to left.
Don't know what you're-
Oh, no, do it from left to right. Because if you did it from right to left, it would be the flip of it. Okay, back to you, Hughes.
Then it would go up 112.5.
Right, it goes up 112.5 to what?
76.5.
76.5, good. And then Mark, what happens now?
So it came up here to, and then we're gonna drop back down,
Diagonal, right?
yeah, and diagonal, we're gonna come down to 72.
Okay, so let's see, so for this section, it was the force is equal to base times height, which was 2 times 18, which is 36. And for this section, we're looking at the force being the base times the height. The base is 4 times 18, what's that, double 36, 72. Okay, tell me again what you're doing?
We're gonna come down diagonally, 72,
Right, so what are we gonna get to?
What's your question? I'm sorry.
Oh, sorry, it says 76.5,
Oh,
and
so
you're
that'll
coming
be
down
that'll be,
72. What?
4.5?
4.5. Okay, what happens next, Tara? In this section 3? Straight across. And then Chris, Al?
I'm a little behind, but, okay, we just dropped down 36, so
That's
we're
right.
at, where are we at right now?
We're at 4.5 above.
Oh. Negative 31.5.
Right, you don't have to put negatives, because you already showed a
Oh.
positive and negative here. And then next, Karen?
Straight across.
Straight across, and then? Chris, Eric?
Up to 0.
Right, and you're going up 31.5 because? Why?
Because that was force and that.
Because there's a 31.5 force. So Wes, what's the maximum shear this beam's gonna experience? What do you want to design it for?
Oh no,
What's the highest number?
76.5?
That's right. If it was drawn to scale, it would be nicer, wouldn't it?
Yeah,
36 is looks a little bigger.
more basement,
Yeah.
Oh, I got it.
Good?
Do you always design a beam for the max shear like everywhere, even though it's
Yeah,
not
because
experienced?
it's one beam. If it was a truss and you had different sections, so everybody heard David's question, if you're choosing one beam, you gotta design it for the max. If you're making a truss, which has all these different members, right, then you can choose different members. The only thing you have to be careful of is if you have 20 different members and you're asking the contractors to be careful, there's more chance of getting mistakes. So the bigger the member, what does that have to do with money? The bigger the material, the more money. One, it's cost per weight, and plus, to get a vehicle to ship something that's heavier is gonna cost more, right? Unless having a sale. So it's gonna cost more to have a bigger member, but if there's the chance that somebody's gonna blow it, right? Some construction guys drinking all night long and then choosing truss members, sure, it's their mistake, but ultimately, in the end, somebody might die, right? So especially like truss members, I don't think are gonna be a problem because you got this huge crane, everybody's looking, everybody could check it out. But how about rebar? What's rebar? It's a reinforcement bar in concrete, right? You want a little concrete slab, right? And you call out 20 different rebars, and you got all these guys crossing, they're gonna make a mistake. And that's not that expensive just to get the biggest one. Just get 20 of the same and you know they'll go in right.
So keep it simple.
Keep it simple.
Keep it simple, simple.
I've heard that before. Okay, moments. These are a little harder. Should we pull out our cheat sheets?